This is another type of problem that you're going to see when you're talking about conversions between concentrations. So in this one we have two solutions, 22.5 milliliters of methanol, and they tell you its density. And then we've got methyl cyanide here, and we know how many milliliters of that and its density. They want to know the mole fraction of the solute and the molality. So the first thing we're going to want to do, let's start with our methanol, because that is going to be our solute, since it is the one being dissolved. And 22.5 milliliters of that times its density, 791 grams per milliliter. Milliliters cancel, and you're just going to end up with grams. That's 17.80 grams. And then to get to mole fraction, we need to get to moles. So moles, the molar mass of that one is 32.05 grams in 1 mole. So that means we have 0.555 moles of methanol. Then we have our methyl cyanide here, and 98.7 milliliters times its density, 0.786 grams per milliliter. We'll get our grams, 77.58 grams, and then we'll go ahead and convert that to moles, because mole fraction's on the way. Its molar mass is 41.06 grams in 1 mole. So you're going to end up with 1.89 moles of your methyl cyanide. Okay, to find the mole fraction of methanol, you need moles of the solute over total moles. So our solute is methanol divided by 0.555 plus 1.89, and that gives us a mole fraction of 0.227. Now if we want to find the molality is moles of solute over kilograms of solvent. So our moles, 0.555 moles of my solute over kilograms of solvent. This is how many grams of solvent I have, so we have to move the decimal over 3 places, 0.07758 kilograms. And so we end up with 7.16 molal. Now, this is a very straightforward problem. Another type of problem that you're going to run into, and this one's very similar, I just used the same type of problem to prove a point here. I have a solution made by dissolving methanol in methyl cyanide, and it has a mole fraction of methanol of 0.227, and they want to know the molality. So going from mole fraction to molality, just a little trick there. If you have the mole fraction equal to 0.227, that's the same thing as saying that you have 0.227 moles and 1 total mole. And that's really the trick there, going from the mole fraction to this sort of setup here. So that's going to be equal to 0.227 moles. Now we know the total moles is going to equal to 1. I know part of it is that 0.227. The other part that has to equal 1 is the amount of the moles of our solvent. And in this case, 0.773 added to 0.227 give us 1. So now I know the moles of solute and the moles of solvent. And that's going to become important when we're converting to molality. So if I have 0.773 moles of solvent, and our solvent is that methyl cyanide, we can convert that in 1 mole. There are 41.06 grams. And so that's 31.7 grams. For molality, we're going to need that in kilograms. All right, so then molality is equal to moles of solute, 0.227 moles, divided by our kilograms of solvent, and gives us a molality of 7.16 molal. So you end up with the same answer, just going about it 2 different ways.